going to develop these special triangles that we use in order to determine sine and cosine and tangent ratios for special angles. So if you haven't seen how they're developed, this may help, and this may help you actually remember how to set them up when you need them. So first of all, we're going to start off here with a unit square of side length 1. And because it's a square, obviously all the side lengths are the same. We've got a right angle here in this vertex, right angle, and all the vertices, of course. What I'm going to do now is I'm going to split this down the middle, draw a diagonal here. So now we can sort of ignore this part up here, because that is no longer part of the triangle that we're interested in. Because we split up this right angle up at the top here, now that's 45 degrees, or pi by 4. And of course that's the same down here. From Pythagorean theorem, we know that the long side squared equals the short side squared plus the medium side squared. And if you were to square 1 and 1, add them together and take the square root for the hypotenuse, we would see that the hypotenuse length is root 2. So the pi by 4 special triangle, the side lengths for the two legs are 1 and 1, and then for the hypotenuse it's root 2. So then, of course, anytime you're looking for the trigonometric ratios, the sine of pi by 4 is going to be, of course, the sine is opposite over hypotenuse, which is 1 over root 2. The cosine of pi by 4 is adjacent over hypotenuse, which is 1 over root 2. And then the tangent of pi by 4 is opposite over adjacent, which is just 1. Sometimes, well, mathematicians don't like when there's a root in the denominator, so they rationalize the denominator, because the denominator here, the root here, is irrational. So we're going to rationalize it by multiplying by 1, and the form that this 1 takes is root 2 over root 2. So root 2 over root 2 as a fraction is just 1. So we're just multiplying this by 1, which doesn't change the value at all. And then it just changes the form of it, just looks different. So that actually then becomes root 2 over 2. We can do the same thing for cosine. Okay, so that's the pi by 4 special triangle, starting with a unit square. When we move on to the other special triangle, now we're going to start off with an equilateral triangle with side lengths of 2. And if it's an equilateral triangle, hopefully we realize that all the angles are 60 degrees, or pi by 3. So that means this one up here is 60 degrees. But I'm going to split that in half and draw a perpendicular, drop a perpendicular there. So that's going to be perpendicular here. There's the 90. And we got a pi by 3 here, and we divide pi by 3 by 2. And that gives us pi by 6, which is 30 degrees. Now we don't need this half of the triangle. And this side length was 2, but now we split it in half, now it's going to be 1. And then again, by Pythagorean theorem, now we're given the hypotenuse. So now we've got 2 squared here. The short side is 1 squared. We have to look for the medium side squared. And then of course we've got 4 minus 1, which is 3, so the medium side is root 3. And then when we find the sine, cosine, and tangent of these angles, we start off with pi by 6. The sine of pi by 6 is going to be 1 over, or opposite over hypotenuse, which is 1 over 2. The cosine of pi by 6 is going to be adjacent over hypotenuse, which is root 3 over 2. And the tangent of pi by 6 is opposite over adjacent, which is 1 over root 3. And then we rationalize it, and then that just gives us root 3 over 3. And then when we look at the pi by 3 angle, the sine of pi by 3 is opposite over hypotenuse, which is root 3 over 2. The cosine of pi by 3 is adjacent over hypotenuse, which is 1 over 2, and then the tangent of pi by 3 is going to be opposite over adjacent, which is root 3 over 1, which is just root 3. Okay, so that's the special triangle for the 30-60, or the pi by 3, pi by 6 triangle. And hopefully, if you have seen it developed like this, hopefully it'll help you remember it.